Um, okay, cool. Thank you so much for being here today. My name is Ridhwana Khan. I am a lead engineer, and I am here to talk to you about caching on Dev. So, awkward story. I did work at Dev up until last week, Tuesday, as a lead engineer for almost 4 years. However, on Tuesday, the dev team were forced to lay off pretty much the entire engineering team. And so I guess my cache got expired. Maybe purged, actually, not quite expired. But on a good note, on a lighthearted note, I feel like I learned a lot at Dev, and I'm glad that I got the opportunity to work with incredible folks at Dev. During that experience, I was able to dive deeper into caching, and now I'm able to stand here today to talk to you about caching. So I like to keep my introductions pretty light and fun-hearted, and to share a little bit of me so that you get to know me before I start talking to you about like a lot of technical things. So firstly, that very awkward photo of me is me speaking at conferences. I really love speaking at conferences. I like writing articles. And now that I'm unemployed, I'll get to do a little bit more of that. And it's mostly because I enjoy sharing my knowledge. I enjoy meeting people from different backgrounds, from all over the globe. And I feel like everyone has a very diverse perspective that gives me a better perspective on different things. I'm also passionate about building diverse and inclusive communities wherever I go. This is a photo from a woman in tech community that I built in South Africa. I've been involved in Railsbridge. I've also been involved in a community where we do the intersection of UX and development, which is really cool. And I think that's one of the things that attracted me to Dev in the first place. They have a very inclusive and welcoming community. So, the most important thing to know about me is I'm a cat mom. I give this little fella, whom I fondly call Zeus, all my love, all the scratches in the world, a very warm bed, a lot of treats. And in return, he gives me lots and lots of attitude. Lots of cat hair all over my clothes. I apologize in advance if I have cat hair on me. And just very few cuddles. Doesn't seem like a fair trade to me. And finally, I am from beautiful, sunny South Africa. Has anyone here been to South Africa before? A couple of people, more than I expected. So I'm going to do a quick tour of South Africa just to show you where I'm from. So this is an aerial view of Cape Town, the city of Cape Town. This is where I stay. Over there, we have a big mountain, just like here, but it's called Table Mountain. It's a prominent landmark. It's called Table Mountain because of its flat table-like structure. This is Cape Point. It's where the Indian Ocean meets the Atlantic Ocean, and it just looks really beautiful. We have beautiful winding roads where the mountains meet the sea. We are very well known for our safaris. We have what we call the Big Five, which is the lion, the leopard, the black rhino, African bush elephant, and the African buffalo. Fun fact, we have these animals on some of our notes as well. But the part that I like best about South Africa is that we're a very diverse country. We have different religions, races, cultures, and just in general, really friendly people. So that was me convincing you to come visit. And when you do, please hit me up. So has any of you heard about Dev or used Dev before? Who has? Okay, a lot of people. For those who have not used Dev, Dev is an online platform that forms a community of software developers where you can share knowledge and support one another. The Dev environment creates a place where you can have network learning and collaborate with each other. Currently, we have about over 1 million developers signed up on the platform. So another really nice thing about Dev is that it's open source. Our repo lies at this URL. It's confusing because it's called Forum, but Forum is just the application that powers Dev. And on this repo, you can explore our code, you can log bugs, you can create feature requests, you can fix bugs. That's really great. And now it's Hacktoberfest, so if you are interested in contributing to open source, it's a great time to do so. Our code is written in Ruby on Rails, and we are server-side rendered app. We have sprinkles of JavaScript for dynamic dynamic components. So what can you expect from this talk? That's a lot of stuff. I'm going to cover it though. This talk is going to be a little bit high level where I introduce different topics on caching, and I'll show examples. We're going to talk about why is Dev a good use case for caching? Why should you cache? What should you not cache? What are the causes and effects of an inefficient cache? And then we'll go through some response caching. It will be broken down into edge, fragment, and browser. And then we'll talk about a few miscellaneous caching techniques, and we will conclude. So the things that I'm sharing with you today are the most valuable lessons that I've learned from my experience at Dev. While some examples I give are presented within the context of Dev, they're actually pretty general strategies that can be applied to your application. Another thing that you can expect from this talk is that I will continuously be saying we, making it sound like I'm still part of Dev. But I can't get rid of that habit as yet. Okay, so at Dev, we often get complimented on the speed of the application. It's really snappy. So if I go here and I play this video, you can see if you refresh the page, it's pretty instant. There's not even a loading spinner. Do it again. Okay, if we go to an article page, no loading spinner. It's really, really quick. So why is Dev so quick? One of the major reasons that Dev is so fast is because of caching. And one of the major reasons that Dev is the perfect use case for caching is because it's pretty read heavy. There are tens of thousands of users all around the world consuming content from Dev at any point of time. That content, once created, very rarely changes. This is what makes it mostly static. But what benefits do we get from caching? Why should you consider caching? Oops. Okay, so why should you cache? Caching is nice because it helps to improve the efficiency of our application whilst also increasing the performance. By adding a cache to the application, a user of the site benefits in numerous ways. Some of these ways are, you'll be able to retrieve content faster for application. You'll be able to, of course, improve the application performance. You'll also be able to accelerate data retrieval. That means that you can decrease the time duration for queries. Caching also increases the input-output operations per second. This improves the read throughput of the system and reduces the response time for very read-intensive applications. In turn, this can also reduce the cost of storage systems if they do charge per request. When we reduce the latency and bandwidth required to access the data, as well, we also end up saving device energy and reducing the energy consumption. But my favorite part and benefit of caching is that we improve the user experience. Faster loading times means a happy customer. Also, you're increasing your accessibility to your website. So in countries where the web infrastructure is unreliable, or perhaps internet speeds are just really slow, we rely on caching to create a more accessible experience. These are just some of the reasons, and we'll talk about more during whilst I talk through the different types of caching. So we talked about what sort of data you should cache, mostly static content. What data should you not cache? So you do not want to cache a page that has dynamic data that is frequently changing, because what's going to end up happening is you're going to end up purging more often, and then you outweigh the benefits of caching. You also don't want to be caching user-specific data, such as account information, that is different for each visitor. That creates just too many permutations of the cache, which would then cause the cache to not really be useful, and sometimes it causes a reversed effect where the application gets really slow. So if I can help it, a general rule of thumb that I apply is I first try to understand the problem at hand. I let the code run in production for a little bit, I monitor the code, and then I optimize it and determine whether I need to add caching or not. If you cache too prematurely before you fully understand the problem, you could end up with a really inefficient cache. An inefficient cache could lead to a lot of detrimental things. The first one is a higher resource usage, because we end up deploying more expensive RAM for caching, but then we're also hitting the server and the database and all our infrastructure pretty often. So all in all, we're kind of adding more resources at the problem, but we're still using all those resources, and hence we're adding to the cost of and the maintenance. We could also end up with a very slow application. Perhaps you end up with a case where, again, like I mentioned earlier, you start caching the current user and you have just too many permutations of the cache, and your data changes so frequently that you end up like hitting the cache and then the server. This can just result in a slower application. You could end up with unreliable data. Perhaps upfront you didn't do a lot of like investigation under which conditions you want to purge this cache. And so you don't purge often enough, and what happens is you just have outdated data and inconsistent data. And finally, the one that resonates most with me is that you could end up with an unpleasant developer experience. Because sometimes if you cache too early, your developers end up having to work around your cache rather than working with your cache. And this can be really, really frustrating. So now that we understand the benefits of caching, what you should cache, what you shouldn't cache, and what an inefficient cache looks like, let's dive into some caching strategies. So let's start off first with response caching. Response caching is one of the most common types of caching, and it accounts for majority of the use cases on dev. As the name suggests, it is when you cache a response of a request. And as a result of doing this, you reduce the number of requests, and you also reduce the load on the web server. So in a typical Rails application, this is what the flow of data looks like. In order to understand how to reduce the load on a web server, you need to actually understand what the web server does. So let's just go through it very quickly. It has been covered in some of the previous talks, so I'll just very lightly sort of touch on it. So the browser will send an HTTP request message to the web server. The web server will then receive that request. It will then go into the router and figure out where does it need to route that code. It will route it to the correct action method within a controller. The controller will run the code, and sometimes it will need to go to the model, and then it will need to get data from the database. The controller basically packages everything, and then the web server Rails generates a view for us. Sometimes, whilst this is happening, the web server will also need to execute sort of asynchronous scripts that happen in the controller. So maybe some background jobs that need to be taken care of, etc. And then the web server basically takes that view as a response message, and it sends it back to the browser. The browser renders the received response, and sometimes it will need additional resources, and it will need to go back to the web. It will need to send a request back to the web server to get more information. So as you can see, we put an enormous amount of pressure on the web server because it needs to process a ton of stuff. We want to ease the load on the web server. And in order to do this, we can actually cache in some places. So there are many places in the stack that you can apply caching. One of the important decisions that you as a developer will make is deciding where in that stack you want to cache. So here are some response caching strategies. We use edge caching, fragment caching, browser caching. So what are they? Edge caching basically allows us to avoid hitting the origin server. Fragment caching is usually implemented in the view layer through Rails, and you can reduce database queries in complex rendering of the UI. The browser caching it restricts requests to never leave the browser. And each strategy is useful for its own use cases, and sometimes you may end up with a combination of these strategies to be most effective for your feature. So each of these strategies pretty much have the same caching pattern in common. They have a requester, they have a caching intermediary, and they have a fallback. Once a requester makes a request, it will go to the caching intermediary. If the caching intermediary has the data, it will return it. If it doesn't have the data, it will need to go to it will need to go to the fallback server and respond from there. And when the fallback server responds to the requester, the caching intermediary will retain that data. And it goes on, so on and so forth. So like I mentioned, you'll see this pattern exist across all the different types that I'm about to talk about. But let's start off with edge caching. If it was possible to have a favorite type of caching, edge caching would be my favorite. I spend a lot of time in this talk talking about edge caching and its particular use cases. So what is edge caching? Edge caching lives between the browser and the web server so that we can intercept requests, thus reducing the need to make a trip all the way to the server. There are many technologies that you can use in order to implement edge caching. Some of them include Cloudflare, CloudFront, Kinster, Fastly, and many more. At Dev, we use Fastly for edge caching. And so some of what I'll be describing in this section is directly related to Fastly. But again, the concepts exist in other caching intermediaries as well. So the way that Fastly works is it caches the content at from our origin server at points of presence all around the world. And these points of presence essentially serve to move memory closer to the end user by adding a machine between the end user and the origin server. So for example, a user like me in South Africa, instead of needing to go to the origin server for all my requests, and the origin server is all the way in the US, I could just query my data from a point of presence if it is cached, and that point of presence is in Cape Town. And also on the edge server, we are essentially rendering a cached version of the page. So that means no computation, no processing, and so it's really fast. So here are some of the benefits of edge caching. We can reduce server load and stress on the origin server. This in turn reduces the load on the database, the network, the back-end services. The benefit for the user is it also improves content delivery and response times of our requests. Caching in its best form enables a more predictable performance. It can even continue showing data when there are network issues. But not only do the users benefit, companies that implement edge caching benefit as well because of the reduced CPU usage, thus reducing costs associated with hitting a web server and a database. I need some water. Okay. So we talked about the patterns that each of the caching strategies follow, and edge caching follows that same pattern. But here I'll describe some of the terms that come with an edge cache. So when a user navigates to a page and it's the first time and we perhaps created the cache or it was refreshed, if they go to this page, it will first hit the edge cache. And that edge cache, if it's the first time that this user is hitting it, it will probably be cold. A cold cache is one that is empty without any data. When you hit a cold cache, your request is labeled as a cache miss, and instead it goes all the way to the origin server. The origin server will then process and get the data, and then it will return it back to the user. But in the process, like I mentioned before, the edge cache will retain that data, and this is the process of warming the cache. So the next time a user requests something, requests that same resource, they will hit a warm cache. And a warm cache is one where data is stored and ready to be served. If a cache is warm, that request will be labeled as a cache hit. Every subsequent user will continue hitting a warm cache up until the time that the cache is expired or purged, and then the process repeats itself. So, and we use an edge cache on mostly static pages, but in the real world, it's very difficult to get a page that's like completely static. There will always be some dynamic bits on the page. When you have more static bits than dynamic bits, then you can use edge caching. However, you may want to deal with the dynamic bits in a different way. So the way we do this at Dev is we basically get our main content from the edge cache, and then we create a second request to the server to populate the data that is more dynamic. So let's look at an example. So this is an article page, and on an article page we have reactions. Reactions are pretty frequently changing things, so over here and over here. When we refresh the page, you'll be able to see that the count of the reaction doesn't come in immediately. Let's do it again. You can see there's a little, not a spinner, but a placeholder. If we open up the network tab, you'll be able to see that on the first request, we get the data from the edge cache. You can see that it was 304, not modified. It hit the edge cache. And then what we do is we query a reactions endpoint, and we bring in the data from the reactions endpoint afterwards. Thus, it populates it at a later stage. Okay. So how do you know if something is edge cache? How do you observe edge caching in the browser? So again, I'm going to play another video. I was just too nervous to do this live. So you go to dev2. We're going to load up an article page. Okay. You're going to load up this particular request. And you'll see over here, this is, I think, the first time that I'm hitting this page. And so it was a cache miss, right? And then you can see over here, there was X cache hits with 0. That means that this node was hit 0 times. And then you can see it was served by cache, I'm assuming this is Denver, I'm not quite sure, and then cache MUC, which I was at the Frankfurt airport when I was doing this, and so it tried to hit the cache in Frankfurt, and then instead it went all the way to the origin server. If we load the page again, which I did, you'll notice it's a cache hit. We've hit this node once, and you can see that now it's loading from a pop called MUC. And that's basically how you can observe when we've edge cached a page. Okay. So within our Fastly configuration, we have something called shielding enabled. And shielding does not come by default. You have to enable it in order to use it. It's basically when one of our Fastly pops is used as an origin shield. This concept does exist in other caching intermediaries, just in different forms. So what is shielding? In order to understand what is shielding, I feel like the best way is to first understand how caching works without shielding. So without shielding enabled, each pop acts independently. So anytime it doesn't have a cached version of the requested resource, it will make a request directly to your origin, even if another pop may be in the process of making that same request. So let's look at this example. We have 3 users, they in different regions, so Lyon, Washington, and Tokyo. Then we have these regional pops, so Fastly Paris, Fastly Virginia, and Fastly Tokyo. And our origin server is in the US. So say, for example, this user in Lyon sends a request. We're going to assume, for the purposes of this example, that these regional points of presence are cold caches, so they have no data to return to the user. So the user in Lyon basically queries Fastly Paris, and it is a cold cache, so it will need to go to the origin server. The origin server will return the data. It will be retained at Fastly Paris, so that becomes warm, and the user gets the data. A user in Tokyo, maybe a few seconds later, requests that same resource. However, this user will need to go through the same process. They'll need to go to Fastly Tokyo, which again, we assume that it was a cold cache. Then it will go to the origin server. The origin server will need to do all their processing again and return that data to the user in Tokyo. So how does shielding affect this? So you can reduce the load on your origin server if you specify one of the Fastly pops as a shield. In this case, we specify in Fastly Virginia as our origin shield. So let's look at how this scenario works. So a user in Lyon, again, requests some data. We're again assuming the regional caches, which are Fastly Paris and Fastly Tokyo, are cold caches. And we're going to assume that on the first hit, Fastly Virginia is also a cold cache. User in Lyon tries to query from Fastly Paris. Fastly Paris's cache is a cold cache. It goes to Fastly Virginia, also a cold cache, and then it will end up at the origin server. The origin server will need to do the work, and then it returns the data all the way back to the user in Lyon, whilst Fastly Virginia, Fastly Paris retain that data. Now, a few minutes later, a user in Tokyo requests that same resource. That user in Tokyo will go to Fastly Tokyo. Remember, it's a cold cache, so then it will go to Fastly Virginia. Because Fastly Virginia was collecting the responses to the request that was going to the origin server, it's warm, which means this user will no longer need to go to the origin server. They will simply get the data from Fastly Virginia, and it will render from that cache, and it will be a cache hit. So what happens is the first user needed to get it from the origin server, but any subsequent user could get it from the origin shield. So from that, these are some of the benefits of shielding. So it increases the chances of an end user resulting in a cache hit. Remember that the user in Tokyo actually ended up with a cache hit. It also means that we do not need to keep re-requesting the same data from the origin server from different caching regions, because it will cache on the shield the first time, and then the other points of presence can use their cache. This further reduces the load on the origin server, which is our main purpose. It's almost like a cache of a cache. In addition, an origin shield can also help prevent a spike of traffic at the origin server just after it was purged. So when caching objects, one of the things that you want to think about is how long do you want the cache to be around until it gets stale. One of the approaches is you want a relatively longer cache lifetime, and then you want to purge that cache on certain conditions. So to expire a cache, what we do is we set some cache control headers. This is a snippet of code from dev. I've taken away all the methods that were not relevant to this example. And the things that you really want to focus on is this max age. And then we'll talk a little bit about the stale whilst revalidate and the stale if error. So max age is a header that sets the time to live for a cache. The time to live is the maximum amount of time that the content will respond to requests from the cache. Thereafter, the cache will need to be revalidated at the origin server. The time to live is usually set in seconds. At dev, we say that the max age default is 1 day, but then what we do is in different controllers, we override that max age. So for example, on a feed, you really wouldn't want it to expire after 1 day. So we set it to 2 hours, so we have like a relatively fresher feed. If you're curious, stale whilst revalidate tells a server to respond with the request from the cache after it becomes stale for a number of seconds, whilst it's still getting the data from the origin server in the background. Stale if error tells the cache to serve the response from the cache after it becomes stale, whilst the origin server is responding with an error. Usually, you want a short stale whilst revalidate because you want more fresh data, and a long stale if error because if your origin server is down, in some scenarios, it's better to actually just continue showing older data rather than an error page. That might not work for all scenarios, but in general, you can sort of use that rule of thumb. So expiring a cache allows the cache to be populated with fresh data periodically. But there are times when you actually want to purge the cache. And purging is the act of explicitly removing content from the cache rather than just waiting for it to expire. So let's consider a scenario, a very common scenario that happens with me is I write an article on dev. I'll check for all the typos. I'll check my grammar. I'll hit publish. and I'll just look at the article and I'll already find all the typos very often. So if we were just expiring a cache after one day, what would end up happening is I would go and edit the article. It would only be expired in one day, which means that users would continuously see that resource with the typo, and then it would expire after a day and be fixed. So instead, what we want to do is we want to purge the cache on the edit action. And that would allow users to be able to see the fresh version of the data after the author edits the article. Some of the things that I've outlined on the slide is just like, so when we load this page, we actually bring in the comments as part of the cache, and we do this for SEO purposes. So even though the comments are a little bit like more dynamic, they're not as dynamic as the reactions, and so we find it acceptable to bring in the comments. And so the arrows on the slide is like the things that, the actions that we purge the cache on. So for example, editing the article, editing the user name, the user image, replying to a comment, adding a comment, etc. So for Fastly edge caching, we send the way that we purge a request is that we essentially send a request to the Fastly API, and then we purge based on the path. Again, this is a code snippet from dev. So what we do is, you can see over here, we use HTTP party, we post the purge URL, and that's how we bust the cache. Earlier in the talk, we talked about how we would not cache the user information, as it would cause a lot of permutations, and it will be very inefficient. So to avoid that happening by mistake, we've put in a module for edge cache safety checks. And so if anyone puts in, tries to cache a page with like current user data, tries to cache specifically with the user data, it will essentially send an error, you may not use current user in the cache code path on our development server. So this is a nice way for folks that are maybe getting into caching, or they're just not super familiar with it. It pops up this error so that we don't cache users by mistake, user data by mistake. So the next type of caching that I want to talk through is edge caching. Fragment caching. That's how much I like edge caching. So while edge caching caches the entire page, fragment caching will cache only fragments of the page. And at Dev, we use it to cache parts of the view. So you may need to cache parts of the view because perhaps your views are computationally expensive, and there are numerous things that can cause slow rendering. Some of them include expensive database queries. I mean, ideally, we don't want the database queries in the view, but crap happens sometimes. There may be a complex view with nested loops. There may be numerous nested partials that can increase rendering time. So all of that causes slow rendering time, and maybe we want to improve that with fragment caching. So fragment caching lives in that part of the data flow, the thing that's in purple. At any time we render a fragment, we check if it basically exists in memory. In our case, we use a memory store, we use Redis. And then it follows that same pattern that we outlined up front. If it's cached, it will return the data from that store. And if it's not cached, we'll have to compute and render the view as normal, and then we'll retain that data in the cache. So this is what a fragment cache looks like. You can see that there's dynamic and static attributes that forms a unique identifier. And our memory store will use the above identifier as the key, and then the values will be the already computed and cached HTML that is usually within the block, but the block was so long and complex that I just put dots to signify that that was the view. So different applications use memory stores in different ways. Sometimes the memory store stores JSON data. Sometimes it stores data from third-party applications, but this is how we use it. The dynamic aspects that make up the cache key allows us to purge the cache. So for example, if we look at this, we'll see like article ID, article.last commented at, and so let's look at article.last commented at. Remember that, so we are caching this comment section, And so when you have a cache key article.last comment at, anytime a new comment is added, it will basically purge this cache. Okay, so how do we observe fragment caching on development? So the first thing we do is we run Rails dev cache, but before we do that, you want to clear the cache using temp cache clear. We spin up a server and we go to the page and we basically refresh it. In the developer logs, you should see something like this. This is the first time that we are hitting this fragment. And so we have a write fragment. And you can see this is the key, so it's whole comment area, and then these are the dynamic aspects of the key. You can see it took some time to render. Also, this is marked as a cache miss, and you can see the duration was 23.9 milliseconds. Okay. Now, on a subsequent load, we're reading from the cache instead of writing from it. Again, you can see the same key with some dynamic attributes, and then you can see it was a cache hit, and this time, it took only 0.6 milliseconds. So it's a big, big, big difference. However, we realize that at times we do overuse fragment caching, and we have room for improvement and cleanup. One aspect to keep an eye on is if the complexity of the keys exceeds the complexity of the content, then you may end up with a circumstance where it takes longer to get the cache key from the store than it is to render the view. I mean, whilst Redis handles that very well, it's very scalable, sometimes the better path is to just optimize your views, optimize your database queries before implementing caching. So we can take fragment caching a step further by implementing something called Russian doll caching. And this to me is fragment caching on steroids. So if you look through the app, you'll be able to see that there's like nested cache fragments within other cache fragments, and this is referred to as Russian doll caching. So let's look at an example of a Russian doll caching to understand what it does. So over on the right-hand side here, this is our navigation links on dev. I know a lot of links. But this here is actually it's configurable on the admin side. So someone in the admin can go, they can create a link, they can update it, they can set the URL, they can set the icon, and they can set the name. So this here is a snippet of code that renders the user-facing portion of navigation links. So over here we have a key, where is that key? Collection, there's an attribute. And what that collection attribute theoretically does is it wraps each navigation link in a cache block. So each object, each of those navigation link items contains its own details. So what happens is if, for instance, the video's navigation link gets updated on the admin, instead of having to update all those navigation links, with Russian doll caching enabled, what we do is we only update the videos link, and the rest of them will still continue rendering from the cache, and the outer sort of cache block will still stay as is. So what it does is it doesn't disrupt the rest of the item's cache, essentially. This results in a huge performance improvement. So the next type of caching we're going to go through is browser caching. And browser caching allows resources to be cached in the browser. They reduce the page loading time and eliminate the need to go to the server. At Dev, like many other companies, we cache static assets like JavaScript, CSS, and images. Browser caching lives there at the top. There's no need to go to the server when we get cache hits. This is also pretty self-explanatory. It follows the same pattern. We check the browser cache. If it does exist, we get it from there. If not, we go to the origin server. So this is an example on Dev where we have a JavaScript file called base.js. And as you can see in the screenshot, it renders a status code of 200 from the memory cache. And that's how we know that it was actually browser cached. If you look at the request URL, you will notice that the file name has a hash which is prepended to the name. So over here, that's the hash. So this is a unique identifier for the file, and it's what we call fingerprinting. The fingerprint is the identifier used to determine whether a resource has changed or not. If a file has been updated on the server, then the fingerprint changes, which results in the browser not having reference to that file name, and hence it will go to the server. You'll also notice that we have a header for cache control. So it says public, smax age, and max age. We set this in our production.rb in Rails. And what do these things mean? So public indicates that the response can be stored in a shared cache. This is usually for things that are not access controlled for restricted users. The max age, just like with edge caching, indicates the number of seconds that the response will remain fresh until it needs to go and revalidate it. We have the max age set to 3,000 days. That's a lot of days. But we use fingerprinting to purge the cache more often, and we rely on that technique. Smax age is pretty much the same as max age, but it's used for shared caches. And so when the browser sees the above cache header, it will know that it needs to look into a cache first before going to the origin server. Besides response caching, we also implement a few other miscellaneous caching techniques. They can be called caching techniques. They can be called performance improvements. It's like on that blurred line that is just like performance improvements. But in order to avoid loading up relationships that have expensive queries, we use a technique that allows us to store a column on a table that already shows the calculated version of a query. So then we don't need to do the computation each time. So let's look at an example. So as an example, we show a counter of records like comments and reactions from each article resource, because remember, on an article, we need to show how many comments there were, how many reactions there were, etc. So instead of running the queries on the article relationships each time that we render that page, instead, we store the count of the records on the article table. So the first query is where, if we didn't have it stored, we'd need to find the article, get a .comments.size, which took, 1.6 milliseconds for the article load and 1.1 milliseconds for the comment count. However, if we just render it from the comments count, which is a column on the article table, then it only takes, 1.4 milliseconds. And we do this by using a gem called counterculture. And what counterculture does is every time someone reacts in the background, it will update the reaction count or the comments count, etc. Similarly, for tag relationships, where we have an article has many tags and a user follows many tags, instead of eager loading a tag relationship on an article each time, like that first example, we use a gem called access taggable on, which again creates a column on the table which contains a string of comma-separated tags. This string again gets updated in the background each time the tag list change. So when you're querying it, it ends up being a lot quicker than going and eager loading that relationship, and that just takes some time. So, to conclude, I'd like to discuss some of the questions to ponder on when trying to determine whether or not to implement caching on a feature. The first thing that I like to ask myself is, how often do I see the data changing? If the answer to that is, it's very seldom, it's relatively static data, then I think caching is a good option. Thereafter, I want to check that I'm not caching user-specific data. And so remember we talked about it earlier, we want to make sure that we're caching the right things. However, before committing to any sort of caching technique, I like to remove caching from the equation completely and observe the code that I've written to determine whether I can first make some code optimizations before I actually implement caching. We want to avoid prematurely caching resources or pages because we've learned the repercussions of an inefficient cache, which can be very detrimental for user experience. Now, if I've done more investigation, I've understood the problem, and I've concluded that caching is actually a good fit for my feature, Then I ask myself some more questions. Ask myself, at what layer of the stack do I want to apply caching? Is the static part of our application sort of the entire page, or is it just like small aspects of the page? Because that would determine whether we want to implement edge caching or fragment caching. Maybe we're getting hit by users globally and we want points of presence in different parts of the world. Then I'd use edge caching. Maybe we want to use a combination of different caching techniques that will fit our application needs better. I also try to think about things like how long do we want the cache to be around? And most importantly, you really should think about what are the conditions that you want to purge the cache on. There's probably many, many more questions that we can ask ourselves. And honestly, there's really like no right or wrong answer here. But as with all performance problems, we encourage folks to analyze the problem carefully, run some tests, and then make the most informed decision. What I discussed today were some of the more common ways that we cache. However, it's just the tip of the iceberg. There's so many more caching techniques that we can apply to our application to such an extent that at some point we could even have our application be available offline. Caching is so powerful when used correctly. And when we add these performance enhancements, we show our users that we value them, we're inclusive, and we care about their data usage and their user experience. With that being said, I'd like to thank you for spending the last 45 minutes, actually 46, I'm a little bit over time. And I hope that you found this talk really informative. I really love feedback, and so if you have any feedback for me, it's always appreciated and encouraged. I don't think we have time for questions, so if you have any questions, pop it in the Slack chat. And finally, I'm going to start looking for new opportunities in a few months. So if you think I could be a good fit for your globally distributed team, come please cash up with me. I'm so glad you all laughed at that. Thank you.